The efficiency of an inclined plane. Simple machines, inclined planes, levers, pulleys, are all very useful. The reason they're very useful is because they require less force to accomplish a task. The trade-off with that is that usually where the force that was required to apply the task would have originally only been required to act over a short distance, due to the simple machine being employed, the force needs to be applied for a much longer distance. Imagine, for example, the difference between hammering a nail and turning a screw with a screwdriver. If you hammer a nail, you need a huge amount of force, but you only need to push that nail in. Let's say it's a 2-inch nail, 2 inches. On the other hand, if you're going to put a 2-inch screw into something, you need to apply less force to turn the screw. But since every turn of the screw only moves the screw itself a small amount deeper into the wood, then you have to turn the screw a lot to get the screw to go the 2 inches in, much more than those 2 inches. As a result, when we consider work, which is force times displacement, just because the force went down, the displacement went up. And often the amount of work required for a simple machine is actually greater than had the simple machine not been employed in the first place. That being said, they're still really, really useful because force is often what's limiting to us. We probably, with our hand, couldn't take a screw and drive it into a piece of wood. But with the help of a screwdriver, doing the same amount of work over a lot longer distance, the lower force we are able to apply to a screwdriver to push the screw in. So the simple machine makes it possible for us to do the task. Let's look at another example here, another simple machine, an inclined plane. And imagine a situation where we have a piano, something very heavy, that we need to get into the back of some big truck. It's a really big truck because I've made the back of the truck 1.2 meters above the ground. So an inclined plane, inclined at 20 degrees, is being used to load a 150 kilogram piano into the bed of a truck that is 1.2 meters off the ground. Due to friction between the piano and the plane, a force of 1,000 newtons is required to push the piano up the plank. Determine the efficiency of the inclined plane. So we're going to be pushing with a force of 1,000 newtons. If we want to know the work, we have to know the force times the displacement of the object. Since we're trying to go up a height of 1.2 meters at an incline of 20 degrees, we can use the sine ratio to figure out the distance that needs to be traveled by this piano on its way up the plank. The distance is the hypotenuse and 1.2 is the opposite. So the ratio of sine 20 is equal to 1.2 divided by the distance traveled. Bringing d up and sine 20 down. The actual distance that's going to be traveled by this plank is 3.51. Or the piano is 3.51. That's the length of the plank that's needed to raise it by 1.2 meters. So the work we're applying a force of 1,000 newtons over a distance of 3.51 meters for a total work of 3,510 Newton meters or joules. So that's the work that we, the workers, I guess, in this scenario, are putting into this piano as we push it up. The question is, what work are we getting out? Well, effectively what we're trying to do is we're trying to increase the height of the piano, or we're trying to increase its gravitational potential energy. So I guess we can think the work out accomplished by this simple machine is equal to the change in gravitational potential energy. The piano has a mass of 150 kilograms. We're assuming we're moving the piano somewhere near the surface of the Earth. And we're going to increase the height of the piano by 1.2 meters. So we're getting a new amount of gravitational potential energy of 1,764 joules. So our efficiency compares the ratio of the work that we put into something to how much useful work or how much work we actually get out of having done that work. Work out. There we go. So we accomplished lifting it 17,000 joules. It cost us 3,510 joules to get that to happen. So the efficiency is about 50%. That actually works out to 0.502, but I just moved it to percent right away. So we lost some energy by using the simple machine, but since we weren't able to physically lift the piano straight up and put it in the truck, that extra amount of energy required is a small price to pay to be able to actually accomplish the thing that we're trying to accomplish in the first place.